And there he is.
Right. So I'm going to talk about this new family of comets that we've discovered with pan-stars. On the left, there's two CFHD images of these Manx comets, and on the right-hand side is its namesake. The reason for it is they're weakly active comets and mostly tailless. So these are objects on long-period comet-like orbits. So far, pan-stars has been the most prolific observer of these objects. Yeah, so they're mostly like weak-level comet-like activity. They're 5 to 6 orders of magnitude less active than typical ice-rich comets. And they have the very first one, C2014's S3, had a similarity with S-type asteroid classes. So the expectation for these objects for inactive comets would be they would have a D or P-type spectrum, and that S-type asteroids contains minerals that cannot form around water. So anyways, the implication was that this inner solar system material was ejected out during the planetary formation stage. So what would make a Manx a Manx? First, it'd have to have a high eccentricity, something close to 1. Their perihelion distance would be where water starts to sublimate, so within 6 AU, and their aphelion distance would be greater than 35 AU. But normally, typically weakly active, so compared to high activity and low activity comets, they'd have a gas production rate of 10 to the 22 molecules per second. On the right-hand side, you can see the first, the C2014 S3 compared to Hale-Bopp, and you can see there's not much of a coma or tail either. From a statistical survey by Karen Meach, she's noted that the Manxes are a wide variety of colors. They range from neutral to very red. So what we really need to understand is what are these objects? So spectroscopic follow-up of his targets soon after discovery is quite essential. Fortunately, most of them tend to go lost because they're not followed up quickly enough. So this just, I'm just going to skip over this, but just to show a quick orbital parameter of some of his Manxes. So the abstract, I kind of propose that I would simulate these Earth-impacting parabolic orbits. This is to show the evolution of the brightness and the motion of these Manx comets as they approach us. These will be coming at high velocities, and their surface reflectivity would be similar to that of an S-type asteroid. They also seem to be made of rocky materials, so they'd have a higher density than long-period comets. So this work is still in progress, but so hopefully at some point I'll be able to demonstrate the relatively short warning times we'll get for these type of impactors. So far, we've generated about 4,000 orbits. The period is greater than 200 years. The solar elongation greater than 60 degrees from the sun. And the heliocentric speeds would be about 98 to 99.9% of escape speed. So I also use the size distribution for size frequency distribution for S-type asteroids and the density there. Right. So again, this is just an example of like the different orbital parameters going into it. So just looking at a plot of it, this is a distribution with respect to the semi-major axis, eccentricity, and H, the absolute magnitude. So for ephemeris, we started from the geocenter and integrated backwards until the object hit about 23.5 magnitude in the V filter. The altitude is greater than 20 degrees, sun below. So at nighttime, I know it says 2 detection to 4 detection, but it's actually just 4 detection tracklets that are processed through Digest 2. And this are some orbital classes that we are interested in. I'm mainly going to look at just the NEO category, which is anything perihelion distance less than 1.3. So using Digest 2, as we've heard, it's a rating for short arcs of small solar system bodies. Essentially, it should be a good indicator of the likelihood that this object is within a certain orbit class. And if it's higher than a score of 65, it would post the NEOCP. So I'm going to present 4 cases, and not all of them would have posted to the NEOCP for follow-up. So first one, this one during the 24 days that it's visible before impact. The score was 100, so we'd see that on the right, on the left-hand side. I've got some orbital parameters, the absolute magnitude, diameter, and the impact velocity at which it would hit, and the kinetic energy that it would release. Here we have so this Digest 2 score remains quite low, up to about 5 days before impact. This one would be, so also on the right-hand side, I've got like the visual magnitude in red the geocentric distance and the angular velocity. But what we're mostly interested in is the orange line. And here we can see that we have 22 days of warning before it hits. And this one is just, so at the start of its visibility will be, so we'd have 6 days and then 5 days before impact, of which it would post to NEOCP. The rest of the time, it wouldn't even pop up. All right, so this is just a summary of what I've shown before, but really the bit of interest is here. So I've run so far only about 183 orbits. So you can see most of his tracklets from his orbits wouldn't even post to NEOCP for follow-up. Of those that would post, we'd only have about 2 lunations worth of observations before impact. And so I'm just gonna show that obviously there's quite a bit of work still to be done on this, quite a lot of orbits that I need to run through and eventually make an assessment of what percentage of these tracklets would never make it due to a Digest 2 score, and whether there's something we could do about that. Ben Bow is a grad student at IFA and is currently working on a size frequency distribution for the Manx Comets, and this will be implemented into this work. So far, I think the Manxes will have very short warning times and will impact us hard. But what we really need to do is improve our understanding of its the composition of these objects and what they're made of.
Okay, thank you. We do have time for questions.
Hi, nice talk. I wonder, you have more spectra because it seems that you made a strong statement on the density and the composition of the Manx Comets. Do you have more spectra than those of C2014 S3, or is only based on this?
I only based on that because that's the only one that I've seen the paper on. I know there's a few more spectra, but I haven't been able to, well,
So,
it's not part of my work.
I wonder if there are more spectra with this,
Yes.
with that you have more Manx Comet with S-type.
I actually don't know what the categories are, so hasn't been published yet, from what I understand. So once Karen kind of publishes the work, then I'll know more about what type. But like for just a start of a project, I use S-type, but once I know more.
Okay, because you also said from neutral to very red, and I want to know what very red means in terms of slope.
I don't know myself.
Because Damocles are very red also, so depends on what you consider very red. If you go to a trans-Neptunian, Damocles are not very red at all.
Yeah.
So if it is 10%, it's red, but not very red. So I wanted to know.
I think I don't know the answer myself. So it's something to.
Thanks.
Yeah.
Okay, I'll comment that there's no such thing as a dead comet. There's just some asteroids are more active than others. I think we better take our break now.